Hello and welcome to your ultimate guide for the C954 OA, Information Technology Management course. My goal today is simple: give you everything you need to fully understand the key concepts, master them, and walk into your C954 OA exam with total confidence. In this video we'll cover computer hardware, software types, network classification, network topologies, wireless technology. With over 100 plus success stories, we have proven our videos will help you pass your exam on the first attempt. And remember, our website offers free exam guides and practice questions to help you ace your C954 OA exam. You'll find the link in the description below, so be sure to check it out and get the resources you need to study smarter, not harder. So let's get started.
Welcome to your complete guide to mastering information systems terminology for your Information Technology Management exam. Today we cover everything you need to pass, including the 6 hardware categories, the major computer types, the 2 software families, networks of every size, architectures and topologies, the core internet protocols, transmission media and the key wireless applications. By the end of this video, you will understand the language every later topic in this course is built upon. This is the vocabulary domain, and roughly 1 in 5 exam questions come straight from these terms. Master this material and you will answer those questions in seconds, saving valuable time for the tougher problems. Before we dive into our first concept, I want to share something valuable for your preparation. I have created over 300 completely free practice questions that work hand in hand with everything we cover today. You will find the link in the description below, so please bookmark it and use it as you study. Let us start with the foundation of everything: computer hardware. Hardware is the physical equipment that captures, stores, moves, and transforms information across an organization. The course groups all hardware into 6 major categories: 2 handle processing and workspace, 2 handle long-term storage and capture, and 2 handle communication with the outside world. The first category is the Central Processing Unit, or CPU, often called the processor. This is the hardware that interprets and executes program instructions and coordinates how all the other devices work together. Think of it as the brain of the machine. Every other device answers to it. Examples include Intel, AMD, and Apple chips. The second category is primary storage, also called main memory, the working memory where instructions and data sit, so the processor can reach them directly. It comes in 2 forms. Random access memory, or RAM, is volatile and clears the moment power is cut. Read-only memory, or ROM, is non-volatile and holds firmware. The third category is secondary storage, the equipment designed to hold large volumes of data for the long term. Unlike RAM, it keeps everything safe even when the power goes off. This is where your operating system, applications, files, and backups live. Examples include hard drives, solid-state drives, optical disks, tape, and USB sticks. The fourth category is input devices, which capture information and commands. Anything that converts the physical world into bits the processor can act on belongs here, like your keyboard, mouse, touchscreen, microphone, and camera. In business, this includes barcode scanners and sensors. Remember, a warehouse scanner that picks orders is always an input device. The 5th and 6th categories finish the list. Output devices let us see, hear, or accept the results of processing, like monitors, printers, and speakers. Communication devices send and receive information between machines, including the modem, the network interface card, routers, and switches. Remember that a modem is always a communication device, nothing else. Now, how does this appear on your exam? You will get a scenario and be asked to name the category. The classic trap is mixing up primary and secondary storage. Remember it this way: RAM is your desk where you work right now, but which clears each night. Secondary storage is your long-term filing cabinet. What we just covered is exactly the type of material you will find in our free practice question bank. These are not just basic definitions either. They are written to test your deep understanding, just like the real exam, with the same scenarios and tricky distractors you will face on test day. Let us move on to computer categories. The course recognizes 8 types, ordered from the smallest and cheapest to the largest and most powerful. As we climb this ladder, 2 things grow together: the number of users supported and the cost. Knowing where each fits lets you match the right machine to the right need. The first 4 are personal, single-user devices. A smartphone is a cell phone that runs apps, perfect for mobile sales. A handheld computer fits in a pocket and has its own power, ideal for warehouse picking. A laptop carries the full technology of a desktop in portable form. A tablet uses a fingertip on a flat screen. Next come the bigger machines. A desktop sits on a desk, too heavy to carry, holding its processor, memory and storage in one box. Then we reach the mini computer, and here is a crucial point. A mini computer is not a small personal machine. It is actually a type of server, built for several people in a small business. At the top sit 2 giants. A mainframe meets the needs of hundreds of people in a large enterprise, powering banking, airline reservations, and insurance claims with legendary reliability. A supercomputer is the fastest and most expensive of all, used for weather modeling and genomics. Remember, mainframes win on throughput, while supercomputers win on raw calculating power. Now let us talk about software, the instructions that tell hardware what to do. Here is what makes this topic easy. There are exactly 2 main types: system software and application software. The whole challenge on the exam is correctly sorting any given program into one of these 2 buckets. So let us make that distinction clear. System software controls how the technology tools work together. Its most important member is the operating system, which manages the hardware and runs your applications. Windows, Mac OS, Linux, and Android are operating systems. System software also includes utility software like antivirus tools and disk optimizers. The embedded operating system runs special devices like a car or an ATM. Application software is different. It is used for specific information processing needs. The actual jobs a business wants done, like payroll, customer relationship management, and project management. Familiar examples include Microsoft Office, the enterprise system SAP, and the customer platform Salesforce. Even a custom program that automates one company's invoices counts. The key is function, not deployment. While we are here, let us cover software licensing, which the exam loves. A network user license lets anyone on the network install and use the software. A site license lets any qualified person in the organization install it, even on a machine off the network which supports remote work. A single user license restricts use to one person. Here is the trap that catches so many students. Antivirus software is utility software, which makes it a type of system software, not application software. The simple memory trick is this: if a program helps the computer run itself, it is system software. If it helps you do your actual work, it is application software. I know we are covering a lot of detailed terms, and you might wonder how to practice applying them all. That is exactly why I built those free practice questions. They help you work through scenario questions that combine several concepts at once, which is precisely how the real exam likes to challenge you. Now let us connect these machines together with networks. The most important way to classify a network is by its geographic reach, by how much physical ground it covers. The course focuses on 3 sizes: the local area network, the wide area network, and the metropolitan area network. Get these three straight and many questions become easy. Let us start small with the local area network, or LAN. A LAN connects a group of computers that sit close together like the machines in a single office or on one campus. It usually reaches no more than a few kilometers, runs over Ethernet cabling or wireless signals, and is owned by the organization itself. Now let us go big with the wide area network, or WAN. A WAN connects a large geographic area like a whole state or country and links many smaller networks such as LANs together. The single best example is the public internet, the largest one of all. These distances mean WANs are usually leased from telecom carriers. Sitting right between those two is the Metropolitan Area Network, or MAN. As the name hints, a MAN spans a city. It is larger than a single LAN but smaller than a sprawling WAN. Think of a network linking all the government buildings across a city, often built on fiber rings owned by a municipality or local provider. Here is a memory trick that locks these in picture-nested circles. The LAN is your office, the MAN is your city, and the WAN is your whole country. They simply grow outward by size. And watch for this trap. When two distant offices connect, each office has its own LAN, while the link between them rides across a WAN. Once computers are networked, we must decide how they share the work. This is network architecture, and the course compares two models. The first is peer-to-peer, where every machine shares as an equal. The second is client-server, where work is divided between the requesting machines and a central provider. Let us look at each. In a peer-to-peer network, there is no central server. Instead, the network relies on the computing power of the participants themselves. Each machine can share its own files and printers with the others while someone still uses it as a workstation. This is inexpensive and easy to set up, a great fit for a home or tiny office. In a client-server network, the work is divided. Client machines handle the tasks closest to the user, while a central server manages shared resources, security, and storage. A special operating system, the network operating system, steers information between machines and manages users. This model centralizes backup, scales to thousands of clients, and is why most businesses choose it. Here is how to choose on the exam. Count the users and ask about staff. A two-person law firm sharing one printer with no tech team is peer-to-peer. A growing company that needs central security and backups is client-server. And remember, the cloud is not an architecture. Software as a service is client-server underneath. If some of these network distinctions feel slippery right now, do not worry at all. That is completely normal, and it is exactly why I created that comprehensive practice question bank. Working through real scenarios where you pick the right architecture for a business is the fastest way to make these ideas truly stick. Let us talk about network topology. Topology refers to the physical arrangement, the actual geometric shape of the computers in a network. In other words, how are the machines laid out and wired together? The course covers 5 main types, and each one carries its own strengths and weaknesses you will need to recognize. First is the bus topology. Here, every device connects to one central cable called the backbone. It is cheap and easy to install for a small network, which is its big advantage. But there is a serious weakness. If that single cable breaks anywhere along its length, every device loses connectivity at once. Picture an old factory floor. Second is the star topology, the most common layout today. Every device connects to one central device, usually a switch or a hub. This makes it wonderfully easy to manage and to add or remove machines. The downside is that everything depends on that central device. If the hub at the center fails, the entire network goes down. Third is the ring topology. Here, devices connect to one another in a closed loop. so each machine links directly to two neighbors. A ring can offer high bandwidth over long distances, which is its strength, but it is expensive and difficult to install, and a single break in the loop can disable the whole network. Fourth is the hybrid topology, which simply combines two or more of the others, most commonly star clusters, joined to a single bus backbone. It gives you flexibility, letting each segment use whatever shape fits best. And fifth is the wireless topology, where devices connect through signals between access points, trading cables for mobility but accepting more interference. The exam often asks you to tell bus and hybrid apart. Hold on to this. A bus connects everything to a single cable, while a hybrid blends two or more topologies for flexibility. To remember them, picture this. The star reaches out from a center, the ring forms a closed circle, and the bus runs in a line. Now we reach one of the most important topics in this whole domain: protocols. A protocol is simply a standard that specifies the format of data and the rules to follow during transmission. Think of it as a shared language. Two computers can only exchange information when they agree to speak that same language on both ends. The most important protocol of all is the Transmission Control Protocol and Internet Protocol, known together as TCP/IP. It was developed by the United States Department of Defense to connect a system of computer networks we now simply call the Internet. It provides the technical foundation for the public Internet and for countless private networks too. The stack is organized into 4 layers, and you should know each one. The application layer is the window through which users and programs reach network services. The transport layer handles moving packets from end to end. The Internet layer formats data into packets and adds the address header. The network interface layer places packets onto the network. Several familiar applications run on top of this stack. File transfer protocol moves files between machines. Simple mail transfer protocol carries your email. The Telnet protocol lets a personal computer act as a terminal for a server. Hypertext transfer protocol lets browsers and servers exchange web pages, and Simple Network Management Protocol manages network devices remotely. How does data actually travel? Through packet switching. The sending computer divides a message into efficiently sized units called packets, each carrying the destination address. These packets may take different routes and are reassembled at the far end. This is why the protocol matters so much. It is universal, vendor independent, and flexible by design. Here is the trap to avoid. The model has 4 layers, not the 7 of the older OSI model. Do not mix the 2 counts up. To remember the 4 in order, repeat this phrase: application, transport, internet, network interface. And always remember that hypertext transfer protocol, the web protocol, lives at the application layer. Remember that mastering these concepts takes practice and real application. The free practice questions are designed specifically to help you turn what you are learning here into exam-ready skills. The 4 layers especially reward repetition, so quiz yourself on them often until naming all of them feels completely automatic under pressure. Let us turn to network media, the physical path that data actually travels along. There are 2 broad families. Wired media, also called guided media, confines signals to a narrow physical path inside a cable. Wireless media uses the natural environment, like the air itself, to carry signals with no cable between the endpoints at all. Wired media comes in 3 types. Twisted pair cable is the cheapest and most common, the copper wiring used for Ethernet inside buildings. Coaxial cable has a central conductor wrapped in shielding, the kind used for cable television. And fiber optic cable carries data as pulses of light, offering the highest bandwidth and the longest distance. Wireless media includes far more than office networks. It also covers microwave links, satellite communication, and infrared. Now here is a trap that trips up many students. Fiber optic cable is not wireless. Even though it carries light, it is firmly a wired medium because that light travels inside a physical glass strand. Microwave, however, truly is wireless. For the exam, focus on matching the medium to the distance. When a scenario asks for a backbone between two data centers many kilometers apart with minimal interference, the answer is almost always fiber optic. Twisted pair tops out around 100 meters before the signal weakens, and coaxial is not built for those long hauls. Now let us explore the wireless network categories. These mirror the wired sizes we learned earlier, but with one extra level added at the very small end for personal devices. There are 4 to know: the personal area network, the wireless local area network, the wireless metropolitan area network, and the wireless wide area network. Let us start at the smallest. A personal area network, or PAN, covers communication between devices owned by one individual over just a few meters, like Bluetooth pairing your phone with a wireless headset. Step up and you reach the wireless local area network, or WLAN, which uses radio signals to cover a few hundred feet, like office wireless. Now let us go bigger. A wireless metropolitan area network, or WMAN, uses radio signals to cover a whole city, like a citywide fixed wireless service. And the largest, the wireless wide area network, or WW1, uses cellular or satellite signals to reach across countries and the globe. Your phone's cellular data connection is a perfect example. The course also adds 2 colorful security terms. War driving means searching for wireless networks while driving past in a vehicle, while war chalking means marking a wall with symbols to show others where access is available. To keep the 4 categories straight, remember the ranges climb from meters to feet to a city to the entire globe. As we move into our final major topic, remember that understanding these terms is only the first step. The real mastery comes from applying them under exam conditions. And that is where those free practice questions become invaluable. They are completely free, built specifically for your success, and waiting for you in the description below. Our final major topic covers 3 wireless business applications you must know. They are radio frequency identification, the global positioning system, and the geographic information system. Students often blur these together, but each does something distinct. One identifies items, one finds locations, and one analyzes geography. Let us separate them clearly so you never confuse them. Radio frequency identification, or RFID, uses electronic tags and labels to identify objects wirelessly over short distances, and it holds the promise of replacing the familiar barcode. The system has 2 parts, a tag with a tiny antenna and a reader that interrogates it. Businesses use it for retail inventory, toll transponders, and asset tracking. The Global Positioning System, or GPS, is a satellite-based navigation system that provides extremely accurate position, time, and speed information. It is operated by the United States Department of Defense, yet receivers worldwide can use it free of charge. Businesses rely on GPS for fleet routing, scheduling field technicians, and recovering stolen assets. The Geographic Information System, or GIS, stores, views, and analyzes geographic data, building rich maps and charts. A classic textbook example is monitoring global warming by measuring how fast glaciers melt. Businesses use it for retail site selection, for insurance risk modeling, and for mapping public health outbreaks. It reveals patterns that numbers alone never show. Here is the distinction the exam tests. Identification tells you an item is here right now. Positioning tells you where on earth a receiver sits, and the information system finds patterns across a region. So positioning is navigation, not mapping, while the information system is mapping, not navigation. Remember it simply as item, place, and pattern. Let us tie in a few cross-cutting terms the exam weaves throughout. Interoperability is the capability of different systems to share data and resources. Bandwidth is the maximum theoretical speed a link can carry, while throughput is the actual data delivered. Latency is the delay of a single packet, and convergence merges voice, video, and data onto one shared network. Let us bring it all together. Today, we journeyed through the entire vocabulary of information systems. We covered the 6 categories of hardware and the 8 types of computers. We sorted software into system and application. We compared local, metropolitan, and wide area networks along with the peer-to-peer and client-server architectures that run on them. We mapped the 5 topologies, the 4 protocol layers, the wired and wireless media, the wireless network categories, and the trio of wireless business applications. Notice how it all connects. Hardware runs software. Software talks across networks, and networks follow protocols. Do not forget to grab those free practice questions from the link in the description. You have just built the foundation that every later topic in this course depends on, so be proud of that. Review this material until each term feels automatic. Then test yourself with those practice questions until you answer in seconds. Walk into that exam calm and confident. Now go put in the practice. You have got this.